All right, so a long time ago when you were in algebra class, they talked about the conjugate of a radical expression. And at the time, they talked about it in terms of rationalizing the denominator. And you kind of sit there and you're like, why do we need to know this? Because all it really does is get the radical out of the denominator. It doesn't really do too much in the terms of that. But here's the thing. In calculus, we get to see how knowing about this conjugate is actually going to simplify our life significantly and allow us to solve problems we would not be able to solve otherwise. So the conjugate is defined where we change the middle sign. So whatever is in the middle, we are going to change that middle sign. And I know this is really silly, but I always think about the C in conjugate, the C in change. We change the middle sign. So the reason why we care about this conjugate, again, we kind of look at it and it's like, why do we really care about it? But when you do have a conjugate, so for example, if I have like the square root of t minus 3, the conjugate of that would be the square root of t, change the middle sign, plus 3. So if I multiply a conjugate by another conjugate, if you just look at the structure of this problem, you're going to have to FOIL it out because you have 2 terms times 2 terms. Now, let's see what happens when we do that. When I take the square root of t times the square root of t, I'll just have 2 of those. Okay, the outer one, we will have a plus 3 square root of t. Inner will be minus 3 square root of t. And the last two, negative 3 times positive 3, will give us negative 9. Now, in simplifying this, we first got to deal with the square root of t times the square root of t. Remember that that is the same thing as the square root of t squared. So these 2 copies of the same square root, they are going to cancel out. And you can see that when you rewrite it as the square root of t squared, because a square root has an understood index of 2, the t squared crosses out. So these 2 copies cancel and we just get t. Now, in the outer and the inner, you notice that you have a plus 3 square root of t and a minus 3 square root of t. So those are also going to cross out. So the outer and the inner are crossing out, and we're left with minus 9. Now, this is not a coincidence here. Anytime you have a conjugate times a conjugate, because of this change in sign here with the negative and the positive, the outer and the inner are always going to cross out. They're always going to cancel each other out. So the whole process of FOILing really is just going to be the first, multiplying the first 2 together and multiplying the last 2 together, because the outer and the inner cancel. So the 2 big things to remember from this example, first of all, the conjugate, you change the middle sign. And the second big thing to remember is that when you have a conjugate times the conjugate, so the only difference is the change in sign in the middle, it's not as much work as a full FOIL out step. A conjugate times a conjugate, the outer and the inner always cancel out, and we're left with just the first 2 multiplied together and the last 2 multiplied together. So conjugate times conjugate, we're not doing the whole full FOIL, we're doing the first 2 multiplied together and the last 2. And we'll see how that's helpful in this next example that we're about to do. But for now, just remember conjugate, you change the sign in the middle, and it's not a full FOIL step, it's a Florida step. It's the first 2 multiplied together, the last 2 multiplied together.